Sometimes on a project, an idea arrives that looks like a piece of hardware would fit right in and work perfectly. And then a pivot happens, and that hardware stays in the box. Well, that's what happened with the Tobii Eye Tracker 5, unfortunately. But recently, I decided to break that box open and see how good it really was. So in this short hardware review video, I will show you it in action, talk about some findings, and then integrate it into a test scene in Unity to see how easy that really is. If you came here wanting an in-depth gaming review, you're out of luck. This is more about quickly integrating it into your Unity project. And just to note, I bought this with my own money and I haven't had any contact with the company about reviewing this product. So let's start with what the Tobii Eye Tracker is. Well, it's an eye and head tracking sensor, which can be used to make your experiences more immersive. I turn my head or move my eyes and the world I see can move as well. Or maybe I aim my weapon using my eye tracking instead of the mouse. Well, what you have been watching so far is me parked in Project Cars 2, and you can see me moving my head in the camera and getting the response in game. Now, installation wise, it was super simple, and it mounts into my workstation straight under my main monitor, with the included Velcro attachment. No custom 3D print mount for this one. I'm not going to go through the software installation because that's really dull, just note that there wasn't any friction in getting this up and running. Now, distance-wise, it seems to be pretty good, with about 3 foot, and then it's got a steep drop-off. Oh, and just to note, it doesn't seem bothered by me wearing glasses whatsoever. So with that introduction out of the way, let's talk about Unity and the Tobii Eye Tracker. Well, one point of friction I've found is that the SDK is not just out there to download immediately. You'll have to sign up on the website and then email the company telling them what you plan to do with the product, and then waiting for a response and a link to the SDK. Don't get me wrong, the turnaround was super quick for this. I had the download in under an hour, but still it's something to consider. Now for the game scenario, we'll be looking at the idea of the classic graphic adventure game Monkey Island, a game I absolutely adore. Now if you've ever played the game, you'll know that when you enter a scene, you find items hidden in the world to enable you to progress. Sometimes these items are quite frustrating to find, and you end up scanning the scene with your mouse cursor. Well, here comes in the idea for the Tobii Eye Tracker. I wanted to know how easy it would be to add in eye tracking so I could scan the scene and have items highlight as my eyes flow over them. Turns out it's super easy. So let's take a look at how we make it. For this experience, I have downloaded the Synty Studios Pirate Pack and also the Synty Studios Particle Effects Pack. And I've added a few sound effects here or there. I'll leave affiliate links in the description for this video if you wish to go and get them yourselves. Now here we can see we have a main character in the scene already set up. And the scene itself is very lively. There's some particle effects going on, there's a boat bobbing in the background. It's a live scene. Very endemic of the genre of the time of Monkey Island. Now, as I move my mouse around the scene, things start to happen. A teleport point comes up, telling us we could move our character to another scene, and if we move across, there's another one going to the market. Now if I move the cursor down, we'll come across the cannon, and the cannon highlights to tell us this is an interactable item. And as we move across, I know where the other item is, it's in the fountain here, and you can see some coins. But as you can imagine, that coins element is quite small to find, and could be quite frustrating for some players. They come in here, they're spending ages moving around, and if I've got lots of items around it, say like books in a library, and I want you to select one book, well, that box collider is going to be quite small, so it might take you quite a while to scan down the bookshelves to find it. And here, for instance, you might be looking around for ages and not actually putting your mouse across the coins. Now, if I interact with those elements, say the coins, I press on them, boom, there goes, we've got some money in our bank. And the same with the cannon. If I press on it, the cannonball fires, and oops, we're going to get in trouble for that one because we've just sunk the ship. Now, let's look at how we actually add in gaze control to this. Because what I want to do is I want to have it so that I move my eyes across the scene and elements highlight, which will make it a lot easier than trying to scan with the mouse point. So the first thing to do is note that all the items here, the harbour, the market, the coins and the cannon, use the item class and they have a box collider. So if we look at and focus on the cannon, you can see there's a box collider around it. And the same with the coins, there's a box collider here as well, which receives the mouse input, and we'll use the same thing for the gaze input. The harbour is the same, quite a big element there. We could have made that smaller, but let's look at how we add in the gaze component to it. So let's jump into our item class, and we could just come up here, press edit script. So the elements in the item class, we have events and we have setup flags. We have items such as the particle system, the animator and the audio source. And these are for things that happen in the world. Audio plays, animator plays a certain animation, and the particle system, like you saw with the cannon and the glowy element over it, will be played. The item can be disabled and it can also be selected. These are the three functions that we're interested in: selected, deselected and pressed. And these are all hit from the input manager, which is doing the actual raycasting from the mouse itself for us. And we're not interested in that. We're interested in adding in some gaze aware components. Let's jump through these functions first. So on selected, we set it to be selected. We play the animation, the audio source and the particle system. We do the same thing, but with the deselection animations, particle systems and audio. And then when it's pressed, we run the event that we're interested in. And for, say, the destination, this might be telling the game manager, move to that destination. Or for the coins, add coins to our purse. Or for the cannon, shoot the cannon and get us in trouble. And we also have a flag here that if this item disables after it's been pressed. And the reason for this is the cannon you only want to fire once, the coins you only want to select once, but let's say there was a parrot in the scene that squawked every time you pressed on it, we'd want to have that be able to be pressed again and again and again, and therefore it would be false, the disabled after pressed element. So jumping back into the scene, what we can do is we can actually select all of our item components and just add the gaze aware component to that. And that's from the Tobii Eye Tracker package that we've installed into Unity here. Jumping back into Visual Studio, we can get that component. So let's do that. We want the gaze aware component, which uses the Tobii gaming library. We want that to be null. And we're going to collect that in our await statement. So let's start writing in our await statement and put in the gaze aware equals get component gaze aware. Okay, so now we've got this component. We know that the gaze aware component only tells us if it has focus. So let's do that in the update statement for this particular class. So in update, we'll say if mGazeAware dot has gaze focus, then we'll select the item. Else, we'll deselect the item. Now this is where these catches come in, because otherwise we just keep running this animation and this audio every time while we're looking at that component. But this basically says set this to is selected, and then we can't come back into it while we've got the focus. So we'll only be focusing on the one time. So let's save that and jump back into our Unity scene. Once that loads, let's press play. And what I'll do is I'll turn on the video capture of myself and also the Tobii Eye Tracker API, well, the experience, and that enables us to actually see where we're looking on the actual scene itself. And now you can see I'm not moving the mouse at all. I'm actually just using my gaze to actually highlight elements in the scene. Now obviously we don't want to use that to select these items. We could do if we stared at it long enough or we'd done a particular action. Some games might want you to do that. But here we just want the actual items to highlight. So as you can see, that was super easy. I just added the gaze aware component and then put in some very basic code into my item class. And now I have gaze and I know something's there so I can select it. Oh, there's my coins. Oh, and I know the cannon's there and I can select that and boom, we've just dropped the boat. Okay, so that's great, but I want bonus points. Now, as I'm looking around in the scene, there's one thing that isn't really interacting with us, and it's the character. Now in these games, what would happen is as I press on the coins, that character would go collect the coins, and when I press on the cannon, that character would go and fire the cannon, look to the destinations, they would head to those destinations. However, when we're just looking around doing nothing, that character is just staring blankly at us while they're doing their idle animation. Now you could have them move around or you could have them doing something funny, etc. But the other thing we can do is if the Tobii Eye Tracker is installed, we can actually have them looking with us as if they're interacting with the scene as much as we are. So what we can do is we can take the head transform for the character and we can make that look at where we look at by taking the gaze point and sending that into the scene and getting that back. So let's do that now. We'll stop the scene and we'll open up the player class. And here we are, the player class. So the first thing we're going to want is we're going to want to get the head transform. So let's get that. Head transform for character, transform, head transform. Let's specify that correctly. Okay, and the other thing we're going to want to do is we're going to want to get the camera. Now you can do this in two ways. You can actually set the camera on the class itself, or you could just ask for the main camera. But we might be using render cameras or something like that. So I'm going to basically set the camera myself. Now, when we're casting from the camera into the scene, we're going to want to set a factor, how much we want to go into the screen to look at, for the player to look at, then that's the player character. Because if you can imagine, I've got the camera here and my player is here. What point from the raycast do we want this character to see where we're looking? So we're going to set a factor. And the reason we'll set a factor is you might want to change that scene to scene, or you might want to tweak that or let your designer tweak that. So we're going to have an element that enables them to do that. And you'll see how this comes together in a second. So serialize field, put in a tooltip, and this tooltip is going to say something like distance factor from gaze point to player. And we'll just want to make sure we spell that correctly. And this will be a float. It will be gaze screen factor. That sounds like a good name for it. And we're going to make this a range because we know we're not going to want to have it massive. So we know we're going to want to go from 0, which will be them looking directly at the camera, to halfway. Anywhere further than halfway, and the character is going to be bending their neck far too much. So we can do it at halfway. So the next thing is we're going to create an update. And we'll use a late update as we're probably going to be doing some animations in the future on our character and making things happen. And we want the head transform to happen after those particular items. So we'll call it a late update. The other thing is we're going to want to do our actual functionality, the stuff we're actually interested in this time around. And this is going to be the face gaze point. And we're going to want to call that from our late update. There we go. Okay, so one thing the Tobii API gives us, and we'll need to get the library in there, is the get gaze point. And this gets the gaze point on screen where the user is actually looking. And this returns one of their own classes called gaze point. There we go. Okay, so now we're going to want to get what that is in screen space. So we'll vector free gaze on screen equals gaze point dot screen. And that gives us our screen space. Now what we're going to do now is we're going to want to create a ray that we can send from the camera in screen space into the world. So ray equals mCamera dot screen point to ray, and we're going to give it our screen space point. And the next thing we're going to want to do is get this distance along the ray that we're actually interested in for where that character is going to look. And what we'll do is we'll do a vector free distance, and we're going to go from the camera position to this character's position, and then we're going to multiply that by our factor. So what that's doing is it means wherever, if we go to another scene and we have our character in a different position, maybe further away, maybe a lot further away, this is still a factor that we can use. And it's a distance between the two. It's not some set point in the world space, because that just wouldn't make sense. And the next thing we want to actually do is get that point in the world. So gaze point in world, and we'll use the get point functionality and the distance we just got to get that point in world. And then the last thing to do is to take the head transform of our character and just tell it to do a look at our gaze point in the world. Nice and simple. So if we save that and go back into our Unity scene, let that boot up, we'll select our character in the scene. So our player, here we are, and we've got our player script already added. We'll need the head transform, and you'll usually find that down in the skeleton, spine, spine, spine. It's down here somewhere. Neck, and this, I believe, is the head. So let's get our player. Let's take our head transform and pop that on there. There we go. And then the next thing is to pop the camera on, and we're going to leave it at 0.5 for the time being. So let's press play again. I'll turn back on my camera and I'll turn back on the experience. And there we go. You can see as I look around the scene, our character looks around in the scene with me. And it just makes the world a little bit more interactive. Brilliant. Those are all of our bonus points. Now, I wouldn't want to force people to buy the Tobii Eye Tracker to play this game. It's not a cheap accessory. It's not too expensive, and if you're doing lots of accessories, it's quite fun to have. But what I would do is have it as an optional extra. So I would note on the website, on the download link, hey, if you have a Tobii Eye Tracker, you can do more with this game and have super fun with it. And as you can see, it's super simple to integrate into your games, so it's quite a bonus. And you saw me playing Project Cars 2 earlier, and that was quite good fun to look around. It makes that simulation just super more immersive. Now, this is my first hardware review for this channel, so let me know by hitting the like button if this sort of addition of content is something you want to see in the future. I don't just want to show you the hardware items in action, but I also want to show you them being integrated into some custom created gameplay. But that's it for this video. Now make sure to check out the other content, and if you haven't done so already, consider subscribing. It only helps this channel grow further and means I can produce more of these videos. And as always, thanks for watching.